I am an artist who works for a technology company, and the art that I do requires balance. That's why those things all fell over so quickly. And I make these little forks that are delicately balanced, but they're too small. So in order to make them bigger, I need technology, and I need them to make them bigger, and I need them to maintain their balance. So with that, I work with Direct Dimensions, which is the industry leader in 3D imaging, probably in the country when you take the broad range of things we work with. The company started based in aerospace, but we scan and model everything industrial. Let me back up. So the technology we're talking about here is 3D imaging technology. So that is the process of digitally capturing or imaging an object of any size in 3 dimensions, which we call data capture, and then manipulating that data into formats for downstream applications, which we call 3D modeling. You can see this is the Lincoln Memorial. I'm focusing my talk today on work we've done in the DC area. So this was interesting. It was actually scanned almost 10 years ago, right after 9/11, actually. So in an effort to show how they can document this. But our work spans industrial applications. We work for NASA. We work with all the aerospace companies. We work with medicine. But my role is to help the artists and art community work with these technologies. On the left, we see digital data capture hardware. I'm not going to get into detail about what those are, but there's lots of different ways we can capture 3D objects. And then there's 3D modeling software, and these are all different things you can do with 3D data once you capture it. So today I'm going to show you a little bit of how in the local DC market we've been working with artists and museums and such. So as a first demonstration of a project, which will show you, this is the Awakening. Is anyone familiar with the Awakening? Okay. So as you know, it moved a few years ago, and if you see, you can see there's a little scanner there in between the arm and the head. We scanned the whole thing in about 5 hours using a spherical scanner. And that scanning that I'm talking about generated 3D data points. Can you see that? So by scanning it, we captured all these locations, millions and millions of locations on these objects, which allowed us then to make a virtual model of the whole thing. And why did we do this? Because in this case, the artist wanted to make sure that it was reinstalled in the same exact way he had painstakingly taken to install it 30 years prior. And now it's at the National Harbor. So what we did in this case was we scanned it, we made a model of it, and we did a site plan that we gave to the engineers to install it. So this gives you a quick example of a 3D imaging project. My job, there's lots of different technologies. They range from very small things and very high resolution to very large things like the Awakening or airplanes or even buildings. I help artists and museums understand what they need and get them the right tool for the job. In this case, you see some different resolutions. Depending on what you're doing, you might need a very high resolution where you can't even see facets or polygons in the data. But off to the right, you see something that's a lot lower resolution, and that works just fine for a lot of things too. Once you have 3D data, you can make things. And I brought some examples. My works here are all rapid prototyping objects where these were grown in 3D, layer by layer, using various technologies. Again, I don't want to get into too much detail about them, but these are examples. And then this is a piece of the Liberty Bell, which we scanned, and it's been CNC milled or cut from material to make this. And we do this all the time for others. We don't own the rapid prototype and CNC milling equipment. There's so many different things out there, so many technologies out there that are accessible to us. We help artists get from A to B. So we work with little guys like me, big guys like Jeff Koons, and lots of local guys. And oops, this is, okay, my picture disappeared. So there's an artist, John Dreyfus. It's a really nice picture. You would love it. Since 2001, he's been working with images of four sculptures of the same thing, ranging from 1 foot to 12 feet. And the point is that John has, over the years, made his object, created it in a new form, a new material, re-sculpted it, made it again, and he's evolved his piece over time with the benefit of the technology. So here's an example where you see the up in here, there's a wax that he carved by hand. Over there are some raw points that were scanned, and this is old. And then that was milled out of foam, which was used as a casting pattern for bronze. Another local artist that used the technology different, gentleman Zachary Oxman. To the left you see his hand-sculpted clay. To the right is his finished enlargement. Well, Zach did something different. First we scanned it, and you can see these are the raw scan data over here. And here's a clean digital model of the sculpture. Well, traditionally what people do is they take a form and they cut it out of foam, or they have it made, in this case, out of rapid prototyping, and then they cast it, and that's it. That's what most people do. They might sculpt a little bit. Well, what Zach did was he used the complex form of the tail and the mane. For those, he cut it out of foam. But for the big body, he built a skeletal armature of crisscross cross sections that he took from this horse, built this skeletal armature, and then cut little pieces of bronze by hand and welded them and hammered them to make the form. I thought it was a really interesting method that he came up with on his own. And now this horse, which is a symbol of work, if you look at it closely, you can see all the work that he did.